right, we are going to get straight into today's notes. Today's notes, we are talking about finding volume and then just some different questions with volume. So I did give you guys a formula sheet, so have that out so you can access this. What I'm going to have you guys do is for every problem, we're going to start by writing the formula. And then actually solving. So for part A, I have given the following figure, find the volume, leave in terms of pi. So this is a cylinder. The volume for a cylinder is V equals pi r squared h. And r is equal to 6, h is equal to 3. So 3 is our height, 6 is our radius. And we're going to leave pi as is, times 6 squared times 3, and then we just simplify after we made those substitutions. So pi times 36 times 3, and then to leave it in terms of pi, it looks like 108 pi inches cubed. Okay, and so you do need to label and make sure you're labeling appropriately. Part B says double the height, find the new volume, again, leave in terms of pi. So that means that the radius is going to stay the same of 6. It says to double the height, and so when you take 3 and you double it, that is 6. Okay? We're going to rewrite the volume of a cylinder, pi r squared h, and now we make our substitutions, and then we will solve. 36 times 6 is 216 in terms of pi inches cubed. Part C says, how do the two volumes compare? So there's lots of ways to compare. Okay. What we're going to do is, one way to compare is to divide. We will go ahead and take 216 inches cubed, 216 pi inches cubed divided by 108 pi inches cubed. And when we divide, we find that it equals 2. And so what we're going to say is the volume doubles when you double height. All right, part D. Part D says now double the radius of the original cylinder. Okay, so that's from part A. And then find the volume. We're going to again leave it in terms of pi. And then how does this volume compare to the one in part A? So this time, the radius, if we take 6 and we double 6, we get 12. And we're going to take the original height of 3. Okay. My volume for the cylinder, the formula is still pi r squared h. Pi times r, which is squared, times h, which is 3. 12 squared is 144 times 3. We multiply that together, we get 432 pi inches cubed. Now, it says to compare this volume to what we found in part A. So 432 pi, we'll just do pi this time, so since we're running out of room, divided by 108 pi, and we get 4. We're going to put this into words. So this time, when you double the radius, the volume is 4 times more. Our next problem, the volume of a cylinder is 405 pi with a diameter of 18. Find the height of the cylinder. Okay, so we're going to write down that formula again. Volume of a cylinder, volume equals pi r squared h. Okay, and then we're going to substitute the information that we know. So we know that the volume is 405 pi. So we're going to leave it in terms of pi. We're going to rewrite pi. Our radius is, so if diameter is 18, radius is half of that, so that's 9. So we'll go ahead and put 9 squared in for the radius. The height is our unknown. We'll leave that as h, and that's what we're solving for. So let's go ahead and start simplifying, because 9 squared is 81. And now I can start getting h by itself. The first thing I'm going to do is to get h by itself is divide by pi. If I divide by pi on one side, I'm going to divide by pi on the other. Notice pi divide out. I have 405 is equal to 81h. To keep solving for h, we're going to divide both sides by 81. So I have h is equal to 5. And let's write this out, that the height of the cylinder is 5 units. Okay, let's go ahead and flip this over to the back. We have a can of soup contains about 553 cubic centimeters of soup. The height of the can is 11 centimeters. What is the approximate diameter of the can to the nearest centimeter? Okay, so it tells us what the cubic centimeters of a soup can. Okay, so let's write that down. 553 cubic centimeters. It tells us that our height is 11 centimeters, and with a can of soup, we know that we're talking about a cylinder. Now let's make our substitutions. Alrighty, so from here we're going to solve for diameter. To find diameter, we have to solve for our radius. So the first thing I'm going to do is divide both sides by 11 pi. And this is something I could have done on the previous problem. Previously, I just took it step by step. So that canceled out. Oops, lost my pencil. I have r squared is equal to about, so we're going to approximate 553 divided by 11 pi. We're going to go ahead and round that to 16. And then to get r by itself, we're going to use our knowledge from Pythagorean theorem. R is about 4, okay? So that's the radius. So that means the diameter is about 8. And then we'll go ahead and write this out, that the diameter of the soup can is about 8 centimeters. Let's go ahead and work on the next one. The Roberts family uses a container shaped like a cylinder to recycle aluminum cans. Again, we're talking about a cylinder. It has a diameter of 1.5 feet and a volume of 2.25 pi feet cubed. If the container is filled halfway to the top, what is the height the cans can reach? Okay, so again, let's write down the information that we know. We know that it has a diameter of 1.5 feet. We know that if that's the diameter and we divide that in half, it is 3/4 feet. And we know the volume is 2¼ pi feet cubed. Since we are talking about a cylinder still, this is pi r squared h. Okay, then we're going to come up with our substitutions to find that height, and then from there we can keep going to figure out half filled. Okay, so to find our initial height, when we make our substitutions, we're going to go ahead and substitute 2¼ pi in for volume. We'll leave pi there. This time for radius, 3/4 squared and h. My first step, what I'm going to do is find 3/4 squared, and I'm going to leave that in a decimal, and that is 0.5625 pi h. Now, to keep solving for h, we'll divide both sides by 0.5625 pi. And we find that h equals 4. Okay? But again, to finish answering this question, if the container is filled halfway to the top, what is the height? Okay? So, we'll go ahead and talk about how, since the container is only filled halfway, the cans will reach 2 feet high. Okay, we have one more problem about fuel tanks, okay? And what we're going to do is find the height for our other fuel tank if they share the same volume. And we'll go ahead and practice this volume problem together in class next time I see you. Okay, thanks. Bye.